Hello and welcome to episode 16 of Chemistry in 15 Minutes or Less. My name is Audra and this review lesson is on chapters 6 and 7, part 9, Energy and Ionic Compounds. Now, energy and ionic compounds is sort of a topic I didn't spend a lot of time learning myself, but ionic compounds minimize potential energy by combining in an orderly arrangement known as a crystal lattice structure. Now, a crystal lattice structure has to do with lattice energy. That is energy released when 1 mole of an ionic crystalline compound is formed from gaseous ions. Now, I've already drawn a quick diagram that goes through a couple of different examples of a specific process creating sodium chloride, NaCl, or table salt. Now, here at 0, this is the initial energy state, which is referred to as delta H. F. There's basically the initial energy. Now, the reactants, in this case solid sodium and chlorine gas, start at an initial energy state that is assigned a value of 0 at 25 degrees Celsius and 1 atmosphere of pressure. So we have, right now, sodium as a solid and chlorine as a gas. Now, energy must be added in order to convert 1 mole of sodium from a solid to a gas. So, that's where 1 is. We go up about 100 kilojoules a mole, which then takes us solid sodium, which, when you add energy, in this case I'm using delta even though that usually means heat, to form sodium as a gas. Now, more energy must be added to remove 1 electron from each of the sodium atoms in order to create the sodium ion, which is number 2, which is the much, much bigger jump, which takes the sodium as a gas with more energy to create the sodium ion as a gas by releasing electrons. Now, the last one, the jump that's kind of small, means no energy is required to convert chlorine into a gaseous state because it's already a gas. However, energy must be added to break up 0.5 moles of the chlorine molecules to produce 1 mole of chlorine atoms. Because chlorine is Cl2, it's bonded with itself. Add some good old energy, and you'll come up with chlorine as a gas, still, but just by itself this time. Now, 4, where it starts to go down, which sounds kind of confusing, because we're already going up and you think we need to add more and more energy, but we eventually have to get back to a solid. Now, some energy is given off when an electron is added to each chlorine atom to form the Cl- ion, and this is an exothermic process. This is what's releasing the energy over here, which is where we take chlorine as a gas, add the electrons we lost over here with sodium to form the chlorine- ion as a gas, and it gives off energy. Now, down here, in order to form the lattice structure, which would sort of be like a crystalline, think of it like scaffolding almost. I'm not going to draw it out because some of them look different, but it's orderly, it's neat, and it helps them fall to the lowest energy state, which as you'll see, it goes down way past the initial value here at 0. This is when much, much, much more energy is given off, when this and this, both the cation and the anion, come together to form sodium chloride, finally. You'll see, all the way down here. It went through this process of adding energy and adding energy. It almost went all the way up to the top here, and then it drops back down to a much lower level. That's all this is talking about. This is tying back to the whole thing, where everything wants to fall to the lowest energy state, and in order to do this, with this specific ionic compound, it goes up, and then it falls way back down. I know that was kind of short, but this chapter is kind of long, and I didn't pay as much attention in class as I probably should have to this, but this should conclude episode 16 of Chemistry in 15 minutes or less. Feel free to leave questions or suggestions in the comments below, and be sure to follow the in-video links, check out the playlist, or head over to my channel for more videos on chemistry review. As always, I do hope this helps, and have a great day.